Okay, let's give you guys some practice, but before I do, let me just give you a quick reminder. When a car is under constant acceleration, remember to the power of -2 here will be acceleration. When a car is under constant acceleration, the acceleration time graph will look like this. Okay, and that will mean the speed time graph will look like this, and the distance time graph will look like this. And when a car is going at a constant speed, to the power of -1 is like speed, and the acceleration here will be 0 because it's going at a constant speed, so there is no acceleration. And the speed time graph for this car here will always be 3. And then that would mean the distance time graph will look like this. Okay, so remember, when given a speed time graph, the gradient of this graph here represents the acceleration, because you can see this is a straight line, y equals mx plus c. This in a way this is like y. This is in a way like y equals m t in this case plus c, where m here is your gradient. Well, the gradient here represents the gradient of the speed time graph represents the acceleration, and then also remember the area underneath the speed time graph represents a distance traveled. Okay, so if you get a speed time graph looking like this, you know that there's no acceleration, because when it's flat, the gradient, remember the gradient of a speed time graph represents the acceleration. Okay, so here the gradient is 0 here, and you can see the acceleration up here is 0. Well, remember, when given a speed time graph, the gradient of this represents the acceleration, and the area underneath the speed time graph represents a distance traveled. Okay, and also if you get given a speed time graph, the gradient of this represents the speed, and then the gradient of the speed time graph represents the acceleration. Okay, so hang on. So first question: given this random graph, what is the acceleration at time equals 7? Okay, so in your mind you've got to picture the 3 graphs. Which graph have I given you? Well, I've given you this one here. So you've got to think in terms of the speed time graph. Anyway, press pause and have a go. What is the acceleration at time equals 7? Okay, so press pause and have a go. Okay, so the acceleration at time equals 7. Well, you've got to decide which graph I've given you. Well, I've given you, hang on, let's go back here. You've been given a speed time graph here. So when you look at this here, and don't forget you've got a gradient here, you've got a slope here. So in a way, I've given you this thing here. Well, it could be this one here, but here there is no slope here, whereas this one there's a slope, which means there would be an acceleration. Well, looking at this graph here, in your mind, you should be looking at you should be picturing these 3 graphs. I've given you the speed time graph, so you should identify this graph in your mind, and now you can see that there's a slope here. Well, if there's a slope here, then there must be an acceleration, because an acceleration would mean there's an increase in speed. Well, there's an increase in speed here. You see that as time goes on, the speed increases. So therefore, there must be an acceleration. So, to answer this question, the acceleration here is really the same as the acceleration here. Well, that's the same as the acceleration here. Basically, you can find well, your job here is to find the gradient at any point on that line. It doesn't matter where. Well, the gradient will be the up and down, which will be 3 in this case, divided by the across, which will be 2. So the gradient of this line here is 3 over 2 over 2. Well, the gradient also represents the acceleration. So to answer this here, the answer here is 3 over 2. It's really you finding out the gradient of this line here at time equals 7. Okay.